Imagine dying 1,000 different ways on a single planet. Being crushed by gravity so intense, your bones would shatter like glass. Falling through clouds made of vaporized metal while acid rain burns through your skin. Or slowly freezing to death on a world where the wind screams at you at 10,000 miles per hour. These aren't nightmares. They're real places. Actual planets floating out there in the universe right now. And today, we're taking you on a tour through the most absolutely terrifying worlds ever discovered by astronomers. Places so hostile, so utterly inhospitable, that they make the surface of the sun look like a vacation resort. We'll visit a planet being slowly devoured by its own star. A world where glass shards fly sideways at supersonic speeds. And a place so dark and cold, it makes the emptiness of space feel warm and cozy. Buckle up, because what you're about to hear will change the way you think about our cosmic neighborhood forever. Let's go. First up, we have what might be the most visually beautiful, yet absolutely deadly planet ever discovered. Meet HD 189333b. A world that from a distance looks like a stunning deep blue marble floating in space. It's gorgeous. It looks almost exactly like Earth from far away. But here's the thing. That beautiful blue color isn't from oceans or a breathable atmosphere. It's from silicate particles in the atmosphere. You know what silicate particles are? Glass. The entire atmosphere is filled with tiny shards of glass. Located about 640 light-years away from us in the constellation Vulpecula, this planet is what astronomers call a hot Jupiter. It's massive, slightly bigger than Jupiter actually, but it orbits its stars so closely that it completes one full orbit in just 2.2 days. That's not a typo, 2.2 days. The temperature on this nightmare world reaches up to 1,700 degrees Fahrenheit, or 930 degrees Celsius, hot enough to melt lead. But the temperature isn't even the worst part. The winds on HD 189333b blow at speeds exceeding 5,400 miles per hour. That's 7 times the speed of sound. Hurricane-force winds on Earth are only about 75 miles per hour. This is 72 times faster than that. Now, combine those two facts. Glass particles whipping around at 5,400 miles per hour in 1,700-degree heat. If you somehow managed to survive the initial heat and pressure, you'd be sandblasted, no, glass blasted to pieces in seconds. The storm would shred through any material we know of like tissue paper. Scientists discovered this planet using the Hubble telescope back in 2005, and they've been studying it obsessively ever since, because it represents something we've never seen before. A planet where it literally rains sideways glass at supersonic speeds. The color comes from the way light scatters through all those silicate particles, similar to how Earth's oceans scatter light to create that blue color we all know and love. Except instead of peaceful water, it's a raging inferno of razor-sharp death. What makes HD 189333b even more fascinating and terrifying is that it's tidally locked to its star, meaning one side always faces the star while the other side is in permanent darkness. This creates a temperature difference of over 500 degrees between the day and night sides, which generates those impossibly fast winds as the atmosphere tries to equalize. Imagine standing on the twilight zone between the scorching day side and the frozen night side. The winds would be strongest there, howling at you with the force of multiple nuclear explosions, carrying with them billions of microscopic glass daggers. There's literally no shield, no protection, no technology we currently have that could withstand those conditions for more than a fraction of a second. This is a planet designed by the universe to be utterly, completely, and absolutely uninhabitable. And we're just getting started. Now, let's travel about 670 light-years away to visit Kelt T9b, a planet so hot that is literally being destroyed by its own temperature. This isn't hyperbole. This planet is hotter than most stars. Kelp-T 9b orbits a star that's about twice as hot as our Sun, and it orbits so closely that it completes a full rotation in just 36 hours. The daytime temperature on this world reaches up to 7,800 degrees Fahrenheit, or 4,300 degrees Celsius. Let me put that in perspective. The surface of the Sun is about 10,000 degrees Fahrenheit. This planet is nearly as hot as the surface of the Sun. It's hotter than some small red dwarf stars floating around in space. At these temperatures, molecules can't exist. The intense heat tears apart hydrogen molecules into individual atoms. The planet is so hot that it's evaporating, literally turning into gas and streaming away into space. Scientists discovered that Kelp-T 9b is losing mass at an incredible rate. It's shedding parts of its atmosphere constantly, creating a comet-like tail of evaporated planetary material streaming behind it as it orbits. If you could somehow stand on the surface, which you absolutely couldn't because you'd be vaporized instantly, you wouldn't see a star in the sky. You'd see a bloated, angry ball of fire taking up half the horizon, radiating so much energy that the entire planet glows like molten metal. There's no day or night cycle in any meaningful sense. There's just eternal, searing, all-consuming heat, the kind of heat that makes iron boil, the kind of heat that would turn diamonds into vapor. The really mind-blowing thing? Kelp-T 9b is still considered a planet. It hasn't been completely destroyed yet, but it will be. In a few million years, this world will be nothing but a fading memory, completely consumed by the very star it orbits. It's like watching a planet slowly die in real time. A massive gas giant, bigger than Jupiter, being cooked alive and torn apart molecule by molecule, and there's absolutely nothing that can stop it. Planet 3, TRES-2b, the darkest planet in existence. From the brightest, hottest hell, we now travel to the darkest nightmare in our galaxy. Say hello to TRES-2b, officially the darkest planet ever discovered. This planet, located about 750 light-years from Earth, reflects less than 1% of the light that hits it. To put that in context, coal reflects about 4% of light. Black acrylic paint reflects about 5%. TRES-2b is darker than coal, darker than the blackest paint. It's essentially invisible. If you could somehow observe it floating in space, you'd see almost nothing. Just a black circle, slightly darker than the emptiness of space itself, with a faint blood-red glow around the edges. That red glow comes from the intense heat. Even though TRES-2b reflects almost no light, it's still a scorching hot Jupiter orbiting very close to its star. The temperature reaches about 1,800 degrees Fahrenheit, hot enough to make the planet glow dimly in infrared. But why is it so dark? Scientists believe the atmosphere contains light-absorbing chemicals like vaporized sodium and potassium, along with titanium oxide. These compounds create an atmosphere so efficient at absorbing light that virtually nothing escapes. Imagine approaching this planet in a spacecraft. As you get closer, you'd see nothing but darkness. No clouds, no features, no surface details. Just an overwhelming void in space that swallows light like a black hole, surrounded by that eerie red glow. Landing on this planet would be like descending into an abyss. Your lights would barely penetrate the thick, light-devouring atmosphere. The heat would crush you, but you wouldn't even see it coming. Just darkness, getting hotter and hotter, until you cease to exist. It's the kind of place that makes you understand why ancient civilizations feared the dark. Because sometimes, in the darkest corners of the universe, there really are things that should terrify us. Planet 4, 55 Cancri E, the Diamond Hell Planet. Get ready for a planet that sounds like a fantasy, but is actually a temperature-regulated torture chamber. Meet 55 Cancri E, sometimes called the Diamond Planet. Located about 41 light-years from Earth, this super-Earth is roughly twice the size of our planet and has 8 times the mass. But here's where it gets interesting. Scientists believe that a significant portion of this planet's mass is pure carbon, and we all know what carbon becomes under intense heat and pressure. Diamonds. The surface of 55 Cancri E might be covered in diamonds, layers upon layers of crystallized carbon stretching miles deep. It sounds incredible, right? A planet made of treasure? Well, hold on. Because the conditions on this diamond paradise are absolutely apocalyptic. First, the temperature. The planet orbits its star so closely that it completes a full rotation in just 18 hours. The surface temperature reaches 4,400 degrees Fahrenheit, or 2,400 degrees Celsius on the day side, hot enough to melt most metals. But here's the truly bizarre part. Scientists have detected that the temperature fluctuates wildly, sometimes changing by hundreds of degrees in a matter of hours. They're not entirely sure why, but one theory suggests that the planet might have massive lava oceans that churn and flow, causing temperature spikes. Imagine a world where the ground beneath you is a sea of molten diamonds and graphite, constantly shifting and bubbling, where the atmosphere is so thick with vaporized rock that you couldn't see your hand in front of your face. The atmospheric pressure on 55 Cancri E is estimated to be crushingly intense. If you somehow survived the heat and toxic atmosphere, the pressure alone would compress your body to a fraction of its normal size. And all of this is happening on a planet that might contain more diamond wealth than exists in all of human history. Trillions upon trillions of carats, worthless because they're completely unreachable, sitting on a hellscape where matter itself exists in states we can barely comprehend. It's the ultimate cosmic joke. Infinite wealth on a planet that would kill you in less than a second. Planet 5, HD 80606b, the Comet Planet. Now we visit something truly unique, a planet with the most extreme climate in the known universe. Meet HD 80606b, a gas giant about 190 light-years from Earth, with an orbit so eccentric that it experiences temperature swings that would make your head spin. Most planets orbit their stars in relatively circular paths. HD 80606b does not. Its orbit is incredibly elongated, almost like a comet's trajectory. For most of its 111-day orbit, the planet drifts far from its star, experiencing relatively mild temperatures around 800 degrees Fahrenheit, still hot by our standards, but manageable for a gas giant. But then, every 111 days, HD 80606b makes a close approach to its star, and this is where things get absolutely insane. In just 6 hours, the temperature on the planet skyrockets from 800 degrees to 2,000 degrees Fahrenheit. That's an increase of 1,200 degrees in less than a quarter of a day. This rapid heating creates atmospheric shock waves that ripple across the entire planet at supersonic speeds. Scientists observed these shock waves using the Spitzer Space Telescope and confirmed something terrifying. The entire atmosphere of the planet reorganizes itself in real time. Imagine if Earth went from room temperature to hotter than molten lava in 6 hours, every day. The devastation would be unimaginable. Mountains would melt, oceans would boil away. The atmosphere would explode into space. On HD 80606b, this happens regularly, like clockwork. The planet swings close to its star, gets blasted with radiation and heat, the atmosphere goes haywire with massive storms and shock waves, and then it drifts away again to cool down before the cycle repeats. If you were somehow observing from the surface, you'd see the star growing larger and larger in the sky over the course of weeks, until finally, it dominated the entire horizon. Then, in those 6 critical hours, everything would turn into chaos. Winds at thousands of miles per hour, temperatures rising by the minute, the sky itself seeming to catch fire. It's like living on a planet that periodically decides to become hell itself, then calms down and says, "Sorry about that, see you next orbit." Then they looked closer and realized they'd found something far more interesting and far more terrifying. Karat 7b is tidally locked to its star, meaning one side always faces the star, while the other faces away into darkness. The day side reaches temperatures of 4,300 degrees Fahrenheit. The night side plunges to negative 350 degrees Fahrenheit. That's a temperature difference of over 4,600 degrees between the two sides, the largest temperature gradient of any planet we've ever discovered. On the day side, the surface is so hot that rocks vaporize, not melt, vaporize. Entire oceans of molten lava bubble and churn, releasing rock vapor into the atmosphere. This vapor rises up, cools slightly, and then condenses back into solid particles. And then it rains rocks. Literal pebbles and stones falling from the sky like raindrops. Except these raindrops are molten when they form and only solidify as they fall. Imagine a rainstorm where instead of water, you're being pelted by red-hot gravel traveling at terminal velocity. The night side is equally hostile, just in the opposite direction. It's so cold that any atmosphere that manages to drift over from the day side instantly freezes and falls to the ground as snow. Except it's not water snow, it's frozen atmospheric gas snow. You have one side of the planet that's a literal hell of lava oceans and rock rain, and the other side that's a frozen wasteland where the atmosphere itself crystallizes and falls like snow. And in between, the Terminator line, where day meets night. Scientists believe this narrow band experiences the most extreme weather in the solar system, supersonic winds rushing from the day side to the night side, trying to equalize the massive temperature difference, constant storms, chaos. Karat 7b is so close to its star that it completes a full orbit in just 20 hours. The intense gravity and radiation from the star are slowly tearing the planet apart, stripping away its atmosphere, bit by bit. In a few million years, Karat 7b might not exist anymore. It'll be nothing but a scattered debris field, the remains of a world that was too close to the fire. Now, let's step back for a moment and ask the really important question. Why do these nightmare planets exist? What does their existence tell us about the universe? First, we need to understand something crucial. These nightmare planets aren't rare exceptions. They're everywhere. Since the first exoplanet was confirmed in 1995, we've discovered over 5,000 confirmed exoplanets, with thousands more candidates waiting to be verified. And here's the shocking part. Most of them are nothing like Earth. For decades, we assumed that our solar system was typical. We thought most planetary systems would have small rocky planets close to the star and large gas giants farther out, with relatively circular orbits and stable conditions. We were completely wrong. The universe is far more creative and far more violent than we ever imagined. Hot Jupiters that orbit their stars in days, super-Earths with crushing gravity, rogue planets drifting through empty space with no star at all, diamond worlds, lava worlds, ice worlds, worlds we don't even have names for yet.
These nightmare planets exist because planet formation is a chaotic, violent process. When a star system is born, you have a massive disk of gas and dust swirling around a young star. Over millions of years, particles collide and stick together, forming larger and larger clumps. Sometimes these clumps become planets in stable, comfortable orbits. Sometimes they migrate inward, getting caught by the star's gravity and ending up way too close. Sometimes they collide with each other, merge, or get ejected from the system entirely. It's not a gentle process. It's demolition derby on a cosmic scale. The planets we've been talking about are the survivors. They're the ones that made it through the chaos, even if they ended up in absolutely horrific conditions. For every planet we can see, there were probably dozens that got destroyed during formation. And here's something that should blow your mind. All of these nightmare worlds are in our immediate cosmic neighborhood. We're talking a few hundred to a few thousand light years away. That's nothing on a galactic scale.
Billions of worlds where glass storms rage forever. Billions of worlds being slowly vaporized by their stars. Billions of worlds locked in eternal darkness or eternal fire. It makes you realize how special Earth really is. We're not special because we're the center of the universe or because we're cosmically important. We're special because, against all odds, we ended up in the perfect spot. The right distance from the right kind of star with the right size, the right atmosphere, the right magnetic field, and the right conditions for liquid water to exist. The chances of all those factors aligning are incredibly small. We won the cosmic lottery. And all around us, in every direction, are the planets that lost. But here's the thing that keeps astronomers up at night. For all the nightmare planets we've discovered, we've also found a handful of candidates that might possibly, potentially, be habitable. Planets in the habitable zone of their stars. Planets with the right temperature range for liquid water. Planets that, from what we can tell with our current technology, might be able to support life. We don't know yet. We're still looking, still searching, still hoping. Because if we can find life on a planet that's not Earth, even if it's just bacteria or simple microbes, it would answer one of the biggest questions in human history. Are we alone? And if we're not alone, then what does that mean? Are there civilizations out there right now, looking up at their own skies, wondering the same thing we are? Are there alien astronomers studying our sun from 64 light years away, cataloging Earth as just another potentially habitable world? The nightmare planets tell us something important. The universe is vast, violent, and overwhelmingly hostile to life as we know it. But life found a way here, on this one tiny blue marble in an ocean of darkness. Maybe it found a way somewhere else too. So what's next? Where do we go from here? The search for exoplanets is accelerating at an incredible pace. Every year we discover hundreds of new worlds. Every year our technology gets better, our telescopes get more powerful, and our understanding of planetary science deepens. The James Webb Space Telescope, launched in 2021, has already begun revolutionizing our ability to study exoplanet atmospheres. JWST can analyze the light passing through a planet's atmosphere as it transits in front of its star, breaking that light down into its component wavelengths to determine what chemicals are present. This is huge, because if we can detect things like oxygen, methane, or water vapor in an exoplanet's atmosphere, we might be able to identify biosignatures, chemical indicators that life might exist there. We're not just discovering planets anymore. We're starting to understand them. We're learning what they're made of, how they formed, and whether they could support life. And the nightmare planets? They're not just horror stories. They're laboratories. Natural experiments happening on a planetary scale that teach us about physics, chemistry, and the limits of what matter can endure. When we study a planet where it rains glass, we learn about atmospheric dynamics under extreme conditions. When we study a planet being vaporized by its star, we learn about stellar radiation and planetary evolution. When we study a planet covered in diamonds, we learn about carbon chemistry and pressure-induced phase transitions. Every nightmare world is a piece of a larger puzzle, a clue to understanding how planetary systems form, evolve, and sometimes destroy themselves. Within the next 10 to 20 years, we'll have telescopes powerful enough to directly image Earth-sized planets orbiting nearby stars. We'll be able to see their surfaces, study their weather patterns, and potentially detect signs of life. The Nancy Grace Roman Space Telescope, scheduled to launch soon, will have the capability to discover thousands of new exoplanets, including many that might be habitable. Ground-based telescopes are getting bigger too. The extremely large telescope currently under construction in Chile will have a mirror 39 meters across. That's massive. It'll be able to study exoplanet atmospheres in unprecedented detail. We're living in the golden age of exoplanet discovery. Our grandchildren will grow up in a world where thousands of planets have been thoroughly studied and categorized, where we might know of dozens of potentially habitable worlds, where the question of extraterrestrial life might actually have an answer. But let's bring it back to Earth for a moment, because there's something important we need to talk about. All of these nightmare planets, as terrifying as they are, serve as a stark reminder of how fragile and precious our own world is. Earth is a paradise, not because it's perfect, but because it's survivable, because we can breathe the air without dying, because water falls from the sky instead of molten rock, because the temperature stays within a range where liquid water can exist and complex molecules can form. We often take this for granted. We complain about the weather, we worry about climate change, we debate environmental policies. And those are all valid concerns. But sometimes it helps to have perspective, to remember that we live on a planet where you can walk outside without being instantly vaporized, crushed, flash frozen, or shredded by supersonic glass storms. That's not a low bar to clear. That's actually incredibly rare. Climate change is real, and it's a serious threat to our civilization. But even in the worst-case scenarios, Earth will still be infinitely more habitable than any of the nightmare planets we've discussed. We're not going to turn into Venus overnight. We're not going to become HD 189733b. But we could make things significantly worse for ourselves if we're not careful. The nightmare planets show us what happens when conditions go wrong, when a planet ends up too close to its star, or loses its atmosphere, or experiences runaway greenhouse effects. Earth could never become as extreme as those worlds. Our orbit is stable, our star is well behaved, and our planet has been fine-tuned by billions of years of geological and biological processes. But we could make things worse. We could make things harder for ourselves and for future generations. So, maybe the real lesson from the nightmare planets isn't just that they're scary. Maybe the lesson is that we're unbelievably lucky to be here, right now, on this world that's so perfectly balanced. And maybe, just maybe, that luck comes with a responsibility. To take care of the one habitable planet we know exists. To preserve it. To protect it. Not because we're afraid of turning into Corot 7b, but because Earth is rare, special, worth fighting for. In a universe filled with glass storms and lava oceans and planets being slowly vaporized by their stars, we found ourselves on a world with forests and oceans and blue skies. That's the real miracle. Now, let's talk about the future of space exploration and what it means for humanity. We've discovered these nightmare planets from Earth using telescopes. We've never sent a probe to any of them. We've never directly sampled their atmospheres or touched their surfaces. Everything we know comes from careful observation and analysis. Light from their stars passing through their atmospheres. Tiny wobbles in stellar motion caused by orbiting planets. Minute drops in brightness when a planet passes in front of its star. It's detective work on a cosmic scale, and we've gotten remarkably good at it. But observation has limits. To really understand these worlds, we'd need to go there, to send spacecraft equipped with advanced instruments to study them up close. And here's where reality sets in. The closest nightmare planet we discussed, 55 Cancri E, is 41 light-years away. With our current technology, a spacecraft traveling at the fastest speeds we can achieve would take roughly 700,000 years to get there. Even if we could develop spacecraft that travel at a significant fraction of light speed, something we're nowhere close to achieving, these planets would still be decades or centuries away. We're not going to visit these worlds anytime soon. Maybe not ever. But that doesn't mean they're not important. Because every exoplanet we discover, every nightmare world we catalog, brings us closer to understanding the bigger picture. How common is life in the universe? How rare is Earth? What are the odds that intelligent civilizations develop on other worlds? These are questions that have haunted humanity since we first looked up at the stars. And for the first time in history, we're starting to find answers. The Drake equation, proposed by astronomer Frank Drake in 1961, attempts to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. It takes into account factors like the rate of star formation, the fraction of stars with planets, the number of planets that could support life, and the fraction of those planets where life actually develops. For decades, we had to guess at most of these numbers. But now, we're filling in the blanks with real data. We know that most stars have planets. That's confirmed. We know that rocky planets in the habitable zone are relatively common. We've found dozens of candidates. What we don't know yet is how often life actually develops. That's the big unknown. Is life common in the universe, arising whenever conditions are right? Or is it incredibly rare? A fluke that only happened once in our galaxy?
The nightmare planets can help answer that question. Not because we'll find life there, we won't, but because they help us understand the range of planetary conditions that exist. If we survey 10,000 stars and find that 9,000 of them have nothing but nightmare planets, that tells us something. It tells us that habitable conditions are rare, that Earth-like worlds are the exception, not the rule. But if we survey 10,000 stars and find hundreds of potentially habitable worlds, that changes the equation. That suggests that life might be common, that we might not be alone. Right now, we're somewhere in the middle. Habitable zone planets seem to exist in decent numbers. Maybe 10 to 20% of stars have at least one. But we don't know how many of those are truly Earth-like. A planet can be in the habitable zone and still be a nightmare. It might have the right temperature, but lack a magnetic field,
allowing solar radiation to strip away its atmosphere. It might have the right distance from its star, but be tidally locked, creating extreme temperature gradients. It might have water, but also crushing atmospheric pressure or toxic chemistry. The search continues, and every new discovery, every nightmare planet, every potentially habitable world adds another piece to the puzzle. In our lifetime, we might get the answer. We might detect biosignatures on an exoplanet. We might receive a radio signal from an alien civilization. We might find definitive proof that life exists beyond Earth. Or we might not. We might search for decades and find nothing but silence, empty worlds and nightmare planets, and no sign of life anywhere. Both outcomes are profound. Both would change how we see ourselves and our place in the universe. If we find life, even simple life, it means we're part of something bigger. It means the universe is alive in ways we're only beginning to understand. If we don't find life, if Earth is truly alone, then that makes us even more special. It makes every human being, every animal, every plant, every microbe on this planet part of the rarest phenomenon in the universe, the only life that exists. Either way, the search is worth it, because the question, are we alone, is one of the most fundamental questions we can ask. And the nightmare planets, for all their horror, are part of that search. They're the failures, the disasters, the cautionary tales. They show us what's possible when planet formation goes wrong. But they also make us appreciate what we have. They remind us that Earth, despite all its problems, despite all the challenges we face, is a sanctuary in a hostile universe. So the next time you step outside and feel the sun on your face, or the rain on your skin, or the wind in your hair, remember that you're experiencing something incredibly rare. You're alive on a planet that supports life, a planet with breathable air and liquid water, and temperatures that don't immediately kill you. You're not being sandblasted by glass storms. You're not being vaporized by stellar radiation. You're not drowning in lava or freezing in eternal darkness. You're here, on Earth, the one place in the universe we know for certain that life can thrive. That's pretty amazing when you think about it. And who knows? Maybe centuries from now, when humanity has spread to other worlds, when we've terraformed Mars or built stations around distant stars, future generations will look back at these nightmare planets and see them differently. Maybe they'll see them as challenges to overcome, as frontiers to explore, as resources to harvest or phenomenon to study up close. Maybe someday what seems impossible now will become routine. Maybe we'll develop technologies that allow us to withstand the heat of Kelb 9b, or harvest the diamonds of 55 Cancri E, or ride the shock waves of HD 8606b. Or maybe not. Maybe some places in the universe are meant to stay beyond our reach. Reminders that, for all our technology and ingenuity, we're still bound by the laws of physics and the limits of matter. Time will tell. But for now, from our vantage point here on Earth, these nightmare planets serve as a mirror. They show us what could have been, what might have been, if a few billion years ago conditions had been slightly different when our solar system formed. We could have ended up as a scorched cinder, orbiting too close to the sun. We could have been ejected from the solar system entirely, drifting alone through the cosmic void. We could have been shattered by collisions, or stripped of our atmosphere, or locked in eternal darkness.
But we weren't. Against all odds, Earth survived. And not just survived, but thrived. Life emerged, evolved, diversified. Eventually led to us, sitting here, contemplating the existence of nightmare planets billions of miles away. It's a long chain of improbable events, a cosmic story 4.5 billion years in the making. And we're part of it. So here's my final thought. The nightmare planets aren't just science. They're not just interesting astronomical phenomena to study and catalog. They're a reminder of how special this moment is, how unlikely our existence is, how precious and fragile our world really is. We live in an age where we can discover planets orbiting distant stars, where we can analyze their atmospheres and study their climates and understand their histories, where we can look out into the universe and see, in stark detail, how many ways things can go wrong. And yet, here we are, still here, still alive, still looking up at the stars and wondering what's out there. Maybe that's the greatest discovery of all, not the nightmare planets themselves, but what they teach us about home. Earth isn't perfect. It's never been perfect, but it's ours. It's the only habitable world we have, and in a universe full of glass storms and lava oceans and endless darkness, that makes it pretty damn special. So let's take care of it. Let's preserve it. Let's make sure that future generations can look up at the stars and be grateful, just like we are, that they were born here, on this tiny blue dot, this perfect storm of unlikely conditions, this miracle of a planet we call home. Because out there, in the vast darkness of space, there are billions of nightmare worlds, worlds where nothing can live, worlds where the very concept of life is impossible. But here, on Earth, life found a way. And that, more than anything else, is the real story. Not the nightmare planets themselves, but the fact that we exist to discover them. We're the universe looking at itself, matter that became complex enough to wonder about other matter, star stuff that learned to study stars. The nightmare planets are out there, waiting, raging, dying, drifting through the cosmic ocean. And we're here, watching, learning, marveling at the sheer diversity and strangeness of the universe we inhabit. That's the journey we're on. That's the story we're part of. And honestly, I can't wait to see what we discover next. Thanks for joining me on this tour through the most horrifying planets ever discovered. If this changed how you see the universe, or if it made you appreciate Earth just a little bit more, then mission accomplished. Keep looking up, keep asking questions, and remember, we're all cosmically lucky to be here. Until next time, stay curious and stay grateful for this perfect little world we call home.
Before we wrap this up completely, I need to tell you about 3 more nightmare worlds that didn't make the main list but are absolutely worth mentioning. Because honestly, the universe keeps finding new ways to terrify us. The Rogue Planet, CFBDSIR 2149. Imagine a planet with no star, no sun to orbit, no warmth, no light, just endless, eternal darkness as it drifts through the void of space. CFBDSIR 2149 is what astronomers call a rogue planet. It was either ejected from its original solar system during formation, probably after a catastrophic collision, or it formed alone in interstellar space through the collapse of a gas cloud. Either way, it's been wandering through the galaxy for who knows how long, hundreds of millions of years, maybe billions, just drifting in complete isolation. The temperature on this world is estimated at around -250 degrees Fahrenheit. That's -160 Celsius. Cold enough that any atmosphere it once had has long since frozen solid and fallen to the surface as ice. If you could stand on this planet, which you couldn't because you'd freeze solid in seconds, you'd see absolutely nothing. No stars close enough to provide meaningful light, just pure, absolute darkness in every direction. The silence would be complete. No wind because there's no atmosphere to create wind, no weather, no geological activity, just a dead, frozen rock tumbling through the emptiness of space at thousands of miles per hour. Scientists estimate there might be billions of rogue planets in our galaxy alone. Billions of worlds that lost their stars and now wander alone forever. It's one of the loneliest concepts in astronomy. And here's what really gets me. Some of these rogue planets might have once had life. Think about it. They started out in normal solar systems, in habitable zones, with liquid water and breathable atmospheres. Then something went wrong. A collision, a gravitational disturbance, and they got ejected into deep space. Any life that existed there would have had weeks, maybe months, to watch their sun getting smaller and smaller in the sky, watching the temperatures drop, watching their world freeze over, knowing there was nothing they could do to stop it. If intelligent life existed on a rogue planet at the moment of ejection, their entire civilization would have been doomed. All their history, culture, achievements, gone, frozen in time as their planet drifted into eternal night. It's extinction on a planetary scale, and it might have happened thousands of times throughout galactic history. The planet with two suns, Kepler 10b, affectionately nicknamed Tatooine after the Star Wars planet because it orbits two stars. Sounds cool, right? Two sunsets every day? Romantic twin stars in the sky? Wrong. It's a frozen nightmare. Kepler 10b is a gas giant about the size of Saturn located 200 light-years away. It orbits two stars that are locked in a tight binary orbit around each other. One star is about 69% the mass of our Sun, the other is only 20% the mass of the Sun. Together, they produce less light than our Sun alone, and Kepler 10b orbits both of them at a distance that puts it well outside the habitable zone. The surface temperature is estimated at -100 to -150 degrees Fahrenheit. It's a frozen gas giant with absolutely no chance of supporting life as we know it. But here's what makes it terrifying: the gravitational dynamics. Imagine being on a moon orbiting Kepler 10b. You'd watch two stars circling each other in the sky, creating bizarre shadow patterns and constantly changing light levels. Sometimes both stars would be visible, creating double shadows of everything. Sometimes one would eclipse the other, causing sudden darkness. The tidal forces from two stars would create gravitational chaos. Any moons orbiting Kepler 10b would experience constant gravitational stress, leading to extreme geological activity, massive volcanoes, constant earthquakes, a surface that never stops moving. And the orbit itself is unstable over long timescales. Eventually, gravitational perturbations from the binary stars might eject any moons into deep space or send them to crashing into the planet. It's a system in slow-motion chaos, beautiful from a distance, lethal up close. And finally, let me tell you about one of the weirdest discoveries in modern astronomy. Kepler 51b, a planet so light and fluffy that scientists nicknamed it the Styrofoam planet. This world is about the size of Jupiter, but has a mass only a few times that of Earth. That makes its density incredibly low, lower than styrofoam, lower than cotton candy. How is this possible? Kepler 51b has an absolutely massive atmosphere. We're talking an atmosphere that extends tens of thousands of miles into space, made mostly of hydrogen and helium with trace amounts of water vapor. The planet is so puffy that if you tried to land on it, you wouldn't find a surface. You'd just keep falling through thicker and thicker layers of gas until the pressure eventually crushed you. It's like trying to land on a cloud, except the cloud is planet-sized, and the deeper you go, the more the pressure builds until you're compressed into a singularity. The atmospheric pressure at what would be considered sea level if this planet had seas is estimated to be millions of times Earth's atmospheric pressure. The temperature rises to thousands of degrees, and there's no solid ground anywhere. You'd be crushed, cooked, and dissolved long before you found anything solid to stand on. Scientists aren't entirely sure how planets like this form. The leading theory is that they're young planets that haven't fully contracted yet, or they're being heated by their star in ways that cause their atmospheres to inflate like balloons. But here's the nightmare scenario. If you were somehow trapped in a spacecraft falling through Kepler 51b's atmosphere, you'd experience a slow descent into hell. At first, it would just seem like thick fog. Visibility would drop to zero. Then the temperature would start rising. The pressure would increase. Your spacecraft's hull would start creaking under the stress. Deeper and deeper, the atmosphere getting denser, the heat becoming unbearable, the pressure mounting. And no matter which direction you tried to go, there would be no escape. No surface to land on, no way to gain altitude. Just an endless descent into crushing, burning pressure until your spacecraft imploded and you ceased to exist. It's death by suffocation, crushing, and incineration all at once, stretched out over hours as you slowly sink into a planet that doesn't have a bottom. Okay, so we've covered 9 nightmare planets now. 9 different ways the universe can create absolute hell on a planetary scale. But let's zoom out one more time and think about what all of this really means. Every single one of these planets formed from the same basic ingredients: hydrogen, helium, heavier elements forged in the hearts of dead stars. The same stuff that makes up Earth, the same stuff that makes up you and me. The difference is just in how those ingredients came together. Orbital distance, stellar mass, gravitational interactions, timing, luck. Small variations in initial conditions led to wildly different outcomes. One planet ends up in the habitable zone with liquid water and life. Another ends up so close to its star that it rains rocks. Another gets ejected into deep space to freeze forever. It's chaos theory on a cosmic scale. The butterfly effect stretched across billions of miles and billions of years. And here's what keeps me up at night. Earth could have easily been one of those nightmare worlds. If Jupiter had formed slightly closer to the Sun, its gravity might have disrupted Earth's orbit, sending us into a trajectory that either burned us alive or froze us solid. If a rogue planet had passed through our solar system at the wrong time, Earth might have been ejected into interstellar space. If our Sun had been slightly more or less massive, Earth would be outside the habitable zone. We won the lottery. Not once, but hundreds of times. Every factor that needed to align for life to develop here did align, against astronomical odds. And now here we are, the descendants of that impossibly unlikely chain of events, discovering planets where everything went wrong, learning from their mistakes, understanding what makes our world special by studying worlds that are anything but. It's humbling. It makes you realize that every breath you take, every moment you're alive, is the result of 4.5 billion years of perfect accidents. The dinosaurs didn't get to contemplate exoplanets. They didn't get to understand their place in the universe. But we do. We're the first species on Earth that can look up at the sky and understand what we're seeing. The first species that can discover other worlds and study them. The first species that can ask, why are we here, and actually start finding answers. That's our gift. That's our responsibility. Not just to survive, but to understand, to learn, to keep pushing the boundaries of knowledge. Because somewhere out there, maybe on a planet we haven't discovered yet, maybe on a world orbiting a star we haven't even looked at, there might be other beings doing the same thing, looking up at their sky, discovering our world, wondering if they're alone. And maybe, someday, we'll find each other, exchange information, share our stories, learn from each other's perspectives. Or maybe we won't. Maybe Earth is the only place in the entire universe where intelligence developed, where life looked at itself and said, I want to understand. Either way, the search continues. The discoveries keep coming. And every nightmare planet we find makes us more grateful for the paradise we have. So here's my challenge to you. Tonight, or tomorrow night, whenever you have a clear sky, go outside and look up. Find the brightest star you can see. Now realize that many of those stars aren't stars at all. They're planets in our own solar system: Venus, Jupiter, Mars. And beyond them, invisible to the naked eye, are thousands of other worlds. Nightmare planets and potential Earths, hell worlds and possible paradises. All of them real. All of them out there right now. You can't see them, but they exist, spinning through space, following the laws of physics, being shaped by gravity and radiation and time. And one day, maybe not in our lifetimes, but someday, humans will visit them. We'll study them up close. We'll learn from them in ways we can't even imagine yet. We're living in the very beginning of the age of exoplanet exploration, the first chapter of a story that will continue for thousands of years. Our generation discovered these worlds exist. Future generations will visit them. We'll colonize some. We'll terraform others. We'll make the nightmare planets into homes. Or maybe they won't. Maybe some places are meant to stay nightmares, meant to remind us that the universe is vast and hostile and doesn't care about us. But that's okay, because we care about us. We care about understanding. We care about exploring. We care about surviving and thriving and building and creating. That's what makes us special. Not our intelligence alone, but our curiosity, our drive to explore even when it's hard, even when it's scary, even when every rational part of our brain says, stay home where it's safe. The nightmare planets are calling to us, not to live there, but to study them, to understand them, to learn from them. And in learning from them, we learn about ourselves, about what makes Earth special, about what we need to preserve and protect. So thank you for coming on this journey with me. Thank you for spending 2 hours exploring the darkest corners of our cosmic neighborhood. Thank you for being curious enough to learn about worlds that want to kill you in increasingly creative ways. You could have watched anything. You chose to learn about nightmare planets. And that says something about you. It says you're curious. You're willing to confront uncomfortable truths. You want to understand the universe even when it's terrifying. That's the spirit that got us to the moon. That's the spirit that will get us to Mars. That's the spirit that will eventually carry us to the stars. Keep that curiosity alive. Keep asking questions. Keep looking up. Because the universe is big and strange and full of wonders and horrors in equal measure, and we're just getting started discovering both. The nightmare planets are out there, waiting, raging, freezing, burning, drifting. And we're here, watching, learning, preparing for the day when we're ready to meet them face to face. That day is coming. Maybe not tomorrow. Maybe not in our lifetimes, but it's coming. And when it does, when humanity finally leaves Earth and ventures out into the galaxy, we'll remember these early discoveries, these nightmare worlds that taught us so much. We'll remember where we came from, this tiny blue marble that gave us life, that nurtured us, that protected us from the hostile universe outside. And we'll carry Earth with us, in our hearts, in our memories, in our determination to survive no matter what the universe throws at us. Because if there's one thing the nightmare planets taught us, it's this. Existence is rare, life is precious, and Earth is a miracle. Never forget that. Stay curious, friends. Stay brave. And stay grateful for this perfect little world we call home. The nightmare planets will still be there tomorrow, spinning through the void, waiting for us to understand them. And we will. One discovery at a time. One breakthrough at a time. One question at a time. That's the human way. We don't give up. We don't stop asking questions. We don't let the darkness scare us away. We shine a light into it. We study it. We understand it. And then we move forward. Into the unknown. Into the mystery. Into the vast cosmic ocean that surrounds us. The nightmare planets are just the beginning. Imagine what else is out there waiting to be discovered. Imagine what wonders and horrors we haven't even dreamed of yet. Imagine a universe so vast and so strange that we'll spend millennia exploring it and still never run out of surprises. That's the universe we live in. That's the reality we're part of. And honestly, I wouldn't want it any other way. Thanks for watching. Thanks for learning. Thanks for caring. Now get out there and look up at the stars with new eyes, with the knowledge that those points of light aren't just distant suns. They're entire solar systems, entire worlds, entire stories waiting to be told. And we're the ones who get to tell them. How cool is that?